Good afternoon, everyone. Welcome to today's lesson, Sec 4 E-Math with me, Teacher Jason, over here. Halfway through the June holidays or June holidays happening in a while, I hope everything is good for you all. Alright, so let's get to the lesson started with me appearing right over here in about 5 seconds. And yes, just make sure you are in the correct lesson if you're attending Sec 4 E-Math with me at 2 o'clock. Alright, so some general rules to take note: just be patient and understanding, observe gracious and respectful behavior even in digital space. Lastly, let's ask good and relevant questions for the lesson. Alright, okay, so what are we going today? Okay, so revision again further up as your exams are coming near halfway through. I think your exams are around in 4 months time, so more revision just to recap the properties of a few things. What are the angles, triangles and quadrilaterals, polygons and circles? So quite a bit of revision over here. So let's get it started, shall we? So first up, we have the type of angles over here. So let's get started. Does anybody want to tell me what do I call this kind of angles over here? So what is the name for such angles? Very good, Irvin. Anybody else wants to try before I get it started? Okay, so first one, I know. Okay, the first angle I have is acute. That's good. Okay, I have most of the responses here. Next one, if I see a square over here, what angle can I call this? What is this angle over here? What is the angle over here? If you know, you can give me everything as well, so to keep this revision fast. Alright, okay, so yes, so the next one is actually very good. I see some responses. Right angles. Very good, Irving. Perfect job. And following up, if I have an angle that's bigger than the right angle, I call this, starts with a O, and it's known as, very good, Irvin. I have obtuse, and most of you as well. Good job. Okay, from obtuse down, if I go to an angle like this, what do I call this angle? Okay, just to recap all the angles that you know. Okay, 180 angles. Okay, so that's a property, Irvin. When you say angles on a line, we refer to this as a particular property where there are multiple angles on a line. In one word, I call this a straight angle. Okay, so take note, it's a straight angle. Okay, lastly, I have an angle that's more than 180 but less than 360. What is that particular name of that angle? What is that name? Okay, it starts with an R. Okay, I'm playing like Wheels of Fortune here. It starts with an R. No worries. Anybody else wants to try? It starts with an R. Okay, so this type of angle over here is what we call a reflex angle. Okay, so all the different names, important to know, because in questions they will tell you to find either the obtuse angle, reflex angle, or if they give you only this or this, you have to know the property. And lastly, knowing acute as well, based on the name. Okay, next up, complementary and supplementary angles. Does anybody recall what do I mean if I have my angles being complementary? So what is the property? Complementary means, what is the particular property I have here? Almost there. It's not less than 90, Irvin. Okay, in fact, before I answer this, anybody else wants to try? Yes, that's right, Dennis. Okay, good job over there. If I sum them, it has to be 90 degrees. That's complementary. What about supplementary angles? Does anybody want to try? What about supplementary angles? Supplementary angles. Very good, Irvin. Anybody else wants to try? Okay, if I sum these two angles, I will have, very good, Denise. Perfect job. 180 degrees. Perfect over here. Now with this over here, we have a few properties we have to go through. In fact, the first one, that is where we have your angles on the line that Irvin mentioned. But in this case, it's not just angles on the line, it's adjacent angles, because the angles are side by side on a straight line. Okay, so these abbreviations, take note. Okay, let me just write it smaller. These abbreviations are very, very important in lessons, alright? Okay, especially when you are actually writing it down. Okay, not lessons, when you are doing your questions, you have to write them down. In this case, why do they sum to 180 degrees? Because of this reasoning over here. Adjacent angles on a straight line. Very important over here. They sum to 180. Okay, now next up, okay, angles at a point. Does anybody recall angles at a point? What is the particular notion over here? What is that particular equation that I can link up over here? Very good, Denise. Anybody else wants to recall and try? So if I sum all these angles, very good, Irving, perfect job. So if I want to sum all of them, it is equals to 360 degrees. Lastly, this is actually very, very likable and very, very popular property that my sec ones like to do. Very good, Irving, immediately telling me the property. Anybody else wants to try? And in this case, if you know the property, give me one pair of angles that are equal based on this property. Anybody else wants to try? Very good. Okay, Irving doing a good job. Okay, but now for the rest, I think you guys got it. Just a little shy here. So over here is what we call vertically opposite angles. And next out, what happens is one pair of angles is A is equals to C, or in this case, I have B is equals to D. Now take note, why do I still want to go through all these properties? If we recap, these properties have to be written down in your working when you actually are doing your question. You have to actually write them down. So example, if you find out that 3 particular angles or maybe even 4 particular angles are in a straight line, you actually have to write the reason down. Very important. And coming to reasons, okay, there's actually more properties over here with these concepts over here. So I believe these are some shortcuts that is likely remembered, recall. Whenever it comes to these properties, your teacher will mention, oh, or in fact I do mention as well. Just remember these 3 alphabets, Z, F, and C. So in this case, for the first letter F, what is that particular property over here? What is that particular property I need to mention? Okay, and with these particular properties, what happens is there must be another thing you have to write down besides the property itself. Okay, over here we know first one. Okay, let me just test you all. What is that particular property? Alright, very good. I have first one, corresponding angles. And because corresponding angles happens because 2 lines are parallel to each other. PQ parallel to RS. You have to write the parallel lines. This is very important. If you don't write this down, marks will get deducted. Just a reminder. And in this case, A is equals to B. Now, next one over here, with corresponding, I have alternate angles. Alright, alternate angles, which in this case, my 2 parallel lines, PQRS, my 2 angles over here. Lastly, with C, I have interior angles over here, with my parallel lines, PQ, parallel to RS. And in this case, what is that property over here? Instead of, okay, is it still A equals to B? Very good, Nguyen. Perfect. Okay, so instead of A is equals to B, anybody else wants to give it a try before I actually carry on? Okay, very good. In this case over here, I have A degree plus B degree equals to 180 degrees. Alright, ZFC, alternate corresponding interior. Just remember these 3 and you guys will be in good hands. Okay, now more properties to come because not everything is just lines. They can form your triangles and quadrilaterals. So from this triangle over here, can anybody name me one property that can come up from this particular triangle over here? What is that property? Any one property that I can get a response from anyone just to get that you understand. Okay, let me give you a hint over here. First one, all the angles will sum up to a particular number. Alright, okay, very good, very good. Okay, Irvin, give it a try. It's not 360. 360 is, if you are referring to the second one, is correct, but I'm referring to the triangle. Okay, so I think you're a little bit confused. Let me just write it down. A plus B plus C, they will sum to 180 degrees, and you have to write the reason because this is the angle sum of triangles. Yes, I like the Eureka moment. That's a good one. Okay, next up, okay, this property is also very important, okay, because if I sum these 2 angles, A plus B, does anybody want to tell me A plus B in this case, what angle does it give it to? Okay, it's not 240. Okay, I think it's just for the next one. Sorry for that. I think there's a lag on my side. Okay, Irving, give it a try. Very good, Isabel. That is the correct theorem, very nice. It's the external angle theorem, or in this case, external angle of the triangle, not just any angle. Very good, Genevieve. Okay, Irvin, give it a try. It's not C, but Genevieve got it right. It's D. So this is actually your Sec 2 knowledge, which you might have not touched on yet. Okay, it's coming to your lesson soon. In fact, it's one of your next lessons. No, you have learned this in Sec 1. Yes, Sec 1. You have touched on it in Sec 1. So you need to recall exterior angles. Alright? Exterior angles A plus B is equals to D. Okay, very important. These are exterior angles. Okay, now next one property that can come up over here. A, B, C, D. Yes. What is this? Okay, so if I sum all of this is very simple because quadrilaterals, very good. Over here, 360 degrees. And this is the reasoning over here. Angle sum of quadrilaterals. Okay, so these are the properties that will come for the first part before we try some questions for today. Okay, so now, what are the type of questions that can come about? Bubble question number 1. In this case, for the next, I would say two bubble questions. They are linked to each other. So give it a try. This will be quite quick. What is angle ABC? Read the question carefully. I'm going to launch it in a few seconds. You have only 30 seconds to answer this. 3, 2, 1, let's go. What is FBD? What is the answer? FBD. Okay. Alright, good job over here. Very nice. That's good to hear, Irvin. That's good to hear. Alright, this is actually from your one of the contents you definitely have learned before, Irvin. Last 10 seconds. I'm looking for FBD. Look at the question. Last 5. Last 4. Last 1. Okay. Alright. So don't overthink. What happens is look at the question. I want FBD. So look at the information of the question again. I have all my angles here. ABF, BCD, and this is a right angle. So ABF is here. BCD is here. And I have my right angle. I want to find. Very nice. Okay, not really opposite angles. Recall. How would I get FBD? FBD is in fact my angle over here. FBD is my angle over here. So what concept is it? It's not really opposite. Okay. Very nice. Parallel angles. In fact, okay, the proper name is we call this letter over here Z. Z links to one word. Okay, which you have to actually write this is the working. FBD is equals to BDC. And the reason is alternate angles. And BF corresponds to CD. Right, very important over here, and therefore the answer is 60 degrees. No working, that's why in this case you have to do it quite quickly, quite fast. Alright, angle is 60 degrees over here. Alright, now moving on to the next bubble question. Okay, given now FBD. Okay, given FBD, I need to find DEF. Okay, so I'll write this angle down for you. This is 60 degrees. Okay, how do I find DEF? This one will take a little bit longer, but again, you're making use of different properties. Alright, launching my bubble launcher. Okay, in 3, 2, 1. Okay, this one will take a little bit longer, but I trust you guys can do it. Alright, so analyze a little bit. Okay, see what properties you can do. Alright, perfect. Doing nice, doing nice. Okay, so I want to find, take note, I'm finding this angle over here. DEF. So what do I still need? Always remember, if you're unable to start your working, work backwards. Work backwards. Okay, sorry for that. I think I'm like writing it wrongly. Okay. Nice. That's good to hear, Irvin. Okay, click the correct option. And for those who have yet to answer, you have 30 more seconds. Alright, 30 more seconds to go. Last 20 seconds. Very nice. Last 10. Okay, for this one, you actually have to work it out. Alright, work it out. Last 4. Last 1. Okay, so I think most of you are a little bit stuck for this one. So let's take a look. Now, we have this angle here, 60 degrees. Now, take note, in this case, recall your parallel lines. Parallel lines will be very, very essential and helpful to you if you were to solve. Look at the question again. AC is parallel to DE. Let's draw my lines. AC, DE. Okay, and I have these two angles over here. 40 degrees, 60 degrees. Always remember what you have. So what is a particular property that you can use? Let's recall. ABC, it's in sort of like a straight line. Okay, it's drawn sort of like a straight line. ABC, DE. Okay, CD is parallel to BF. CD parallel to BF. Okay, so it's sort of like a straight line when they are combined together. Now take note over here. How would I start this? Sorry about that. How would I start this? 60, 40. I know these two angles. So what is one particular property I can come about? Recall, these two are parallel. I have, and I'm interested in this angle. So this is like a quadrilateral. I'm interested in this angle. What is this alphabet over here that links to finding one of the angles? You realize I can actually find BDE first. And this is actually using the property of 180 degrees because all these angles, 60, 40, this is one angle, this is another angle, they sum to 180. So minus ABD. Okay, so this is one thing you actually have to visualize it. In this case, my interior angles, the previous angle does not have to be one angle itself. So interior angles, AB parallel to DE. That's the first one. This is equals to 180 degrees minus 60 plus 40 as highlighted by the blue color line here. Okay, this is equals to 180 minus 100. This is 80 degrees. 80 degrees. Now from here, how can I find DEF? It's much easier now because I have this quadrilateral here. So that's why in this case, you actually have to view it and see all the particular properties that you will need to utilize. Which in this case, I have DEF, which is equals to 360 minus 90 minus 80 minus 60. And what is the reason here? I am using, which in this case 130 degrees, angles sum of quadrilaterals. Angle sum of quadrilaterals. So that is the reason why you need to know your properties well, and hopefully this gives a further recap for you all. Alright, now with bubble question number 2, this is one kind of question that can come about. What is another kind of question that can come about? So look at this. I have PQRT is a parallelogram. It's a different question already, so take note. Read the question carefully. R over here is a point on the line QS. So this tells you it is a straight line. So sometimes you have to see the question carefully whether it is a straight line or not by these particular pointers. R is a point on the line QZ. It tells you QRS is a straight line. And after that, next one, very important. What does it mean when the line RT bisects angle PTS? Okay, how do I solve QPT? Alright, very important. How do I solve QPT? Launching my bubble launcher in 3, 2, 1. Let's go. Alright, very nice. I have my options coming in. That's a good sign over here. Alright, take a close look. What are the few things you can get? Yeah, so be very careful, Irvin. Alright, very, very careful. You have to be very strong in your properties. Alright, this is all your triangle properties, which is actually touched on in Sec 1. Alright, so be very careful. And in fact, I may not be able to see your reasons clearly, but in your exam, please write down your reasons clearly. Okay, very, very important. What do I have? I have 50 more seconds, alright, and the response are going good so far. Response are going good so far. Okay, last 28 seconds. I want QPT. QPT is this particular angle over here. Okay, 30 more seconds. Alright, my responses are going good. Last one. Perfect. Alright, getting better, but don't worry, for those who didn't got it correct, listen to my explanation, alright? So, the first thing that comes to your mind is RT bisects angle PTS. It will mean only one thing. These two angles are equal. But, you cannot just write it down like this, you have to state it out. So, STR is equals to, in this case, PTR. Okay? Which is equals to 24 degrees. What is the reason? Question says so, but you have to write it out. RT bisects actually PTS. Angle PTS. Because if you write PTS, what is it? Is it a triangle? Is it an angle? Very, very important over here. So what happens is this. Now, I want to find this angle QPT. There might be two ways. One, we can find this angle, or immediately we can do this because it is a parallelogram, guys. It is a parallelogram. So since these two lines are parallel and these two are straight lines, we can use one thing straight away. We can straight away say QPT is equals to 180 degrees minus, in this case, PTS. What is PTS? 24 plus 24. What is the reason why? Can anybody tell me? Why can I do this? Just a recap again to get your concepts down. What is the reason why I can do this to get me the correct answer? 132. Some of you all will want to find this angle and then say this. It is also fine. But the reason over here is I can say, because it is very good, Genevieve, interior angles. Or in fact, if you forgot and if you realize, oh, I like to solve this angle, then I do opposite to make use of the parallelogram. Also okay. Whatever works in this case. Okay, so interior angles are PQ parallel to ST. Remember, when you do parallelograms, when you have parallel lines, making use of properties involving parallel lines, you have to include my parallel line over here. Very important. Very, very important. Alright, but good job for the response so far. Alright, now that's about it for the first part of the questions. Let's move on to the next part of the recap over here. Now, if we were to picture, regardless of my polygons over here, whether in this case, if you look over here, whether it is a regular polygon or an irregular polygon, does anybody recap or recall what is the formula for sum of interior angles? What is the sum of my interior angles? What is that particular formula that comes into mind? Okay, in this case, my sum of interior angles refers to the yellow color ones. Does anybody recall? It's quite a string of formula over there. Okay, seems like it takes a while, but very good. Okay, I see some responses. It's actually a number of sides minus 2 times 180 degrees. Now, exterior angle, does anybody recall? It's just a number. Sum of exterior angles equals to, what is that number I'm looking for? Very good, Denise. Anybody else wants to try? Starts with 3. Alright, perfect. I'm seeing a string of responses, 360. Very good. Lastly, sum of adjacent and interior and exterior angles, okay? Follows a particular property. What is that number? Starts with a 1. I think I virtually gave out the answer when I say that. It starts with a 1. Alright, perfect. It's just 180 because they are on a straight line. Interior, we call is the one inside. Exterior is outside. Put them together, 180. Alright, moving on, okay? Specifically for regular polygons. And what are they? Regular means they all have equal side length, equal interior angles, and equal exterior angles. Because they are regular, each of the sides have to be the same. So with that, because exterior angles is 360, some of them, each exterior angle will be 360 degrees divided by n. Number of sides will just be divide each angle. Okay, these type of questions will come up quite promptly. Exterior angles. And it's the sum of them. It's the sum. Over here, it's not just one exterior angle. No. Each exterior angle, sorry about that. Each exterior angle. Because each one has a side involved. So 360 divided by exterior angles. Each interior angle, same thing over here. You have the total angles. And then what I do over here, just recap, divide by the number of sides. So it's just a follow-up from the previous formula. Example, exterior angle, sum, finding each one, divide by number of sides. Or if you find number of sides, divide by each exterior angle. Interior angles, this is the sum, divide by each side. That is an important notion over here. Alright, now with this, let's have a question. Typical kind of polygon question, shall we? Okay, so look at it over here. Okay, I don't know whether you can see my screen clearly. Let me just swing through. It looks a bit blurred. Let me see on my side. Okay, it's clear over here. Very good. Okay, so look at this question. Very typical question. A, B, C, D, E represents a section of the n-side regular polygon. Take note, when I say regular, you have to keep in mind, but just take note, is it whether this question or not? Okay, and again, when you have regular polygons, what are things that come to mind? Hexagon, what does hexagon mean? Square, I believe you all know what's a square. Okay, how do I find, in this case, the value of n? And over here, take note what are they referring to. Look at the diagram carefully. I'm just going to stop here. We have 2 minutes to solve this. Launching the bubble launcher in 3, 2, 1. Let's go, guys. You have 2 minutes. Let's go. Let's see how we can find this. Alright, good job. But take note, I want to find a particular value of n. What should I do? First things first, ask yourself, hexagon means what? Okay, find the value of n. What will I have? Okay, sorry about that. Okay, I know my head just got cut off. Alright, hang in there with me. Alright, you guys are always doing good. You guys are doing awesome regardless of where you are. So just hang in there with me. Try your best to solve this question, alright? 1 minute left. Seeing the responses is going good. Alright, perfect over here. You have 50 seconds left, alright? So just hang in there with me. 50 seconds left. Alright, look at the responses. So take note, you have a hexagon, you have a square. To find the value of n in this case, n refers to which one? I hope you guys realize it's this one. How many sides are there? Very important. Last 28 seconds. Last 15 seconds. Hanging there with me, guys. Last 5. Alright, 4. Doing good. 3, 2, 1. Alright, good job. I think I have more than half of you all getting it right. But for those who did not get it right, try to follow my explanation. Alright, now let's go. So, to find the value of n in this case, we call the topic recap. We want to find the number of sides. In this case, it will be better if I can find one of the angles, interior angles, say BCD. Now, how do I find BCD? It will be better if I know this angle. And in fact, this is even better. I know a square. And I can use angles at the point. So what happens? Let's find BCF first. Now BCF, I know it's a regular hexagon. So let's recall. What is BCF? It's an interior angle. How do I find it? N 6 minus 2. And in this case is 6 for my hexagon. Multiply by 180 degrees. Divide by number of sides. 6. Solving this, I'm going to get 120. So therefore I know, okay, this is 120. Now, next up, what can I do? I know this is 90. So all in all, I can just find let me just write down first. DCF is 90 degrees. Just state it out. So they have a thought process. Very important. After that, I can find BCD. Remember, properties are very important. So how do I solve this? 360 degrees minus 120 minus 90. What is the reason? Write it down. So it's going to be angles at a point. This is equals to 150 degrees. Okay, so one way you can do it, you can straight apply, or if you want, you can straight apply the exterior angle formula, which is I go and find each exterior angle. Now, some of y'all may ask, teacher, why don't I just do n minus 2 times 150 divided by n? Now, in this case, take note, I don't know what is n. I'm finding the value of n. So that's why in this case, I use exterior angle, because we call the exterior angle does not involve n itself. I don't know n. But this one, you recall, I know each exterior angle in this case is 30 degrees. Okay, recall, it's just 180 minus the interior angle. Okay, because adjacent angles on a straight line. Okay, how do I visualize this? Okay, let's say my angle is here. Okay, let's say this is my angle. Exterior angle, recall, is just this angle over here. Okay, then after that, I can just do, I think most of you got it, n is 360 over 30, which is 12. So that's where I have answer number 1. Now, a lot of properties comes into mind. That's why you have to be very particular on what other properties to use to solve. And usually, we use exterior angles, because interior angles, recall, my formula is quite complex. I need to find n. I don't know n. How do I even use this? So, a lot of things comes to mind over here. Okay, now, we have one more question before a further recap. And this one, it's a very typical question, I would say. If you see, you will understand what I mean. And this emphasizes a lot, I repeat, a lot on your exterior angles. That's a very big hint already. Start on the exterior angles. And I'll stop there. If I give too much, I think the answers will be too obvious. Alright, launching my bubble launcher. 3, 2, 1, let's go. Let's go, let's go, let's go. Okay, this will take a while, but okay. Do it slowly, alright? Exterior angles, okay? Use my exterior angles. It will help you a lot. Start with exterior angles. Again, read the question carefully. It's a mixture of interior angles and exterior angles. And you have to understand what's the notion of remaining. This is quite hard, so don't worry. You have a while more. Alright, getting my responses in. About 30 seconds left. Give it your best shot. Recall, the hint over here is to use my exterior angles. Let me write down the first statement to see whether it can give you all the few seconds to catch up. Sum of exterior angles is equals to, recall the property, 360. This is just the topic recap. How can I go on from there? Very nice. I'm seeing the responses coming in. Last 10 seconds. Alright, going good. Last 3. Okay, looking at my responses, let me take a look. Okay, not too bad. 1.5 of you got it right, but let's see how we approach this. Remember, sum of exterior angles is 360. What does it mean? The exterior angle involving this one, and the rest over here, the exterior angles equals to 360. So let's form my equation and see how it goes, alright? So I have my first one. Recall exterior angles is just subtracting them. Next one also involves subtracting from 180. Third one as well. So it's plus, sorry for that, it's not minus. Subtracting. And I have 4 off. I don't need to subtract that because that is my exterior angles already. And then lastly, the remaining interior angles. Now, can anybody tell me how many interior angles I have left? Write your response. I want to see anybody gets it there. How many interior angles I have left? Look at the question. How many interior angles I have left from here? Here I have n. I have 7 already. How many interior angles I have? Okay, looking at the response. Alright, good, like getting good. Alright, awesome. So I have, take note, okay, Irvin, this is the interior angles or exterior angles I've written down. I have 4 of them already. I have 3. So I have 7 already. So how can I still have 6 left? We don't know because it starts off with n. Okay, but go try, Irvin, go try. I have 3 plus 4. I have 7. How many I have left? Total, I have n. How much left? Minus the 7 I have left. So this is the hard part. This part you will have to get based on knowing that I have n first. How do you get 13? Take note. How do you get 13? I only know is n first. What is the remaining sides? N minus 7. Yes, 6 plus whatever that is. Or in this case 7 because 3 plus 4. Okay, how do you get 6? Okay, take note of your calculations. N minus 7. You understand what I mean when I solve later. Alright. So, n minus 7, each one of them is the interior angles. But take note, I'm solving for exterior. So I have to do 180 degrees minus, in this case, 175 degrees. All this equals to 360. And from there, your calculations, just take note. Put this all into your calculator, press it out. You're going to get 325. Over here is your linear equations, 5n minus 7. This is equals to 360. And from there, you solve 5n minus 7 is equals to, in this case, 35. N minus 7 is then equals to 7. Okay, so calculation error over there, Irvin, just take note. And for the rest who got it wrong as well, just take note. N is equals to 14. So what is the hardest part? The hardest part is, okay, first step using exterior angles. Second part, which of these are my interior angles? How then do I make use of the exterior angles? Usually exterior angles, because the formula is straightforward. Okay, you don't have any manipulations. It's just sum of it equals to 360. How do I gather all my exterior angles and solve them accordingly? Which in this case, that's why your answer is 14. Alright, very, very important over here. Okay, now, with this last part, let's move on to the recap for my circles, shall we? Circles. First one, I have OQ perpendicular to PR. What is this property over here? Anybody wants to try? Okay, I think this one I'll just rush through a little bit, okay, so that I'll have more time for you to think for the questions. Tangent perpendicular to radius. Okay, recall this is my tangent, PR, radius, OQ. Next one over here, I have something that cuts in the middle and it's perpendicular to this chord. We call perpendicular to this chord. Very good, Dennis. Very fast. Do you want to try the next one? What is that property over there? Okay, I have a line that cuts through here and it's perpendicular to this particular chord. We call the chord is just two things written up. Very nice. Okay, but in this case, for abbreviation, we can just write perpendicular bisector of chord. So all these properties that comes to mind, if you're rusty, time to recap a little bit from here. Very important. Okay, more properties to come. Sorry for that. Okay, sorry for that. Okay, let me just, I think there's some technical errors over here. Okay, next up, angle properties of circles. Angle properties of circles. Can anybody tell me over here, based on all these properties over here, what is the angle I'm looking at? What is the angle property? Very nice, Denise typing out. But in this case, you can just write angles at center. Sorry for the hiccup in the middle. Angles at the center is equals to 2 times angle at circumference. Okay, angles at circumference. Alright, moving on, more angle properties. What is the first one over here? What does it mean? Okay, this is supposedly going to be angles in somewhere. It is 90 degrees because it is angles in a, okay, let me just write it out. I think good job over there, semicircle, okay, because it cuts through the center and the diameter is from here. Next one over here. What do I call this particular one? Now, this is the one that confuses most people. Okay, what do I call this property over here? Okay, so for this one, I think it takes a while because it's hard, but it's angles in the same segment. Now, for this one, I will do a little bit of guidance. What is in the same segment over here? This one, if you were to draw my segments out, this one and the other segment, I draw this one over here. If I were to draw my dotted lines, just visualize this. If I were to draw my dotted lines over here, this one says these two are in the same segment because they're touching here, whereas the other two are in a different segment, so they follow the same segment on the red one. Sorry for that, the red one. So this is one way whereby I can link my two segments together. So to color code nicely, QPR, QSR, it's the red color one. PQS, PRS, it's my blue color one. So just take note from there. That's very important. Alright, lastly, I have this angle property. Does anybody wants to try? They have two names for it. They have two particular names. Anybody else wants to try? Okay, so it's in a quadrilateral, and look at the color code, something I'll do with the color code over here. I have two names for it. Okay, so some of you may have known it as angles. Okay, good try, Irvin, but this is not vertically opposite. Vertically opposite, you will need my angles to cut through like an X. In fact, there's no X over here, so don't worry about it. This is actually gone through in Sec 3. So what happens is this is about angles in opposite segments. You will learn this in Sec 3, so don't worry, Irvin. And also what happens, this one, it's more clear. We call this also the opposite angles in a cyclic quadrilateral. But what happens? Okay, which name do you use them? Which name do you use them? Alright, moderator, please assist Denise. Thank you very much. Okay, so what happens? The name that we usually use in the reasoning is this reason over here. This is the reasoning that we use at the bottom here. But the understanding behind it, we will use this one. Opposite angles in a cyclic quadrilateral. So this one and this one. That is the main reason that you will use over there. Alright. Now, hopefully, it starts over here with understanding all your geometric properties before we get ahead with this one. So look at it carefully. Bubble question 6. A lot of properties. So get the content of the diagram down. Okay. So circle with center O. AC is a tangent at B. Okay, so making use of these properties and look at the question carefully. I have DFE to be this one, okay, BDF to be this one, and DBF. Okay, I'm gonna highlight for you all because it's hard. This whole angle is 69. I want BFO. So what is BFO? I'm gonna stop here. Let y'all try. Launching the bubble launcher. You have 1 minute 30 seconds in 3, 2, 1. Give it a try. Let's go. Okay, Denise, maybe it will be helpful if you let the moderator know the brand of the laptop you're using. Alright, that will be helpful. Alright, for the rest, you have about 1 minute and 15 seconds to go. Okay, see how you will solve it. Okay, let me just drink up. Alright, so over here is making use a lot of the properties over here. So just try your best to see what property you can use. And focus on the angles first. Don't get distracted by all the diagrams. Focus on the angle you want to solve. What is BFO? We call BFO is over here. Now, what are the properties I can use to solve this? Okay, I'm going to stop here. Let y'all try for the next 35 seconds. In fact, look at it closely. The center is O. So what are the further things you can decipher from there? Very important. Last 14 seconds. Give it a shot. Very nice. Very, very nice. Last 3, 2, 1. Okay, not too bad. More than half of you all got it. Let's see. Okay, so Denise, try to follow the lesson from here. I will actually get this down to the tech group. All right. Or moderator, maybe you can send the email to the care email to Denise so she can actually surface this and they can assist her better if you're not able to help. All right. Okay. Now in this case, let's go back here. We know in this case, because OB is the radius, OF is the radius, we can try to see what we can do from here. And after that, what can we solve? Now, it will be good if I actually know, since this is isosceles, it will be better if I know this angle as well, right? So how do I know this? Looking at the top, I can actually get BOF. That is where I use one of the first properties. This is actually 56 degrees times 2. This is equals to angle at the center. This is equals to 2 times of angle at my circumference. So with that, I have 1, 1, 2. Now BOF is 1, 1, 2. Now from here, what can I do further? That's where I can get BFO straight away, which is 180 minus 112. I divide by 2. Why is this so? Because this is equals to 34. Okay, what is the reason? Okay, there are 2 reasons to do actually. No, 1 reason actually. No, 2, sorry. 1 is because it's the angle sum of triangles, and because I'm looking for the base angles of my isosceles triangle. That is why I can actually get to my answer 34. Very important over here. Very, very important. Okay, now, what are the other type of questions that can come up? You guys will be surprised. From here, I know that BFO over here is 34 degrees. So, what is my next angle? I need to find FBC. So, what is FBC? Okay, FBC, I will stop there for a while. Yes, I will stop there and let you guys solve. Launching the bubble launcher in 3, 2, 1. Let's go. Okay, this one should be rather quick if you know your properties well. So take note, I know from part A, okay, I'm not giving the answer because part A is just my angle BFO is 34 degrees. So what can I do next? What is another property I can use? Look at the question. What is the angle I'm finding? The last 25 seconds. Give it a shot. So remember, if you're stuck at a particular question, always recall the geometric properties that you have touched on. And then from there, how you would solve it. And lastly, positive mindset. I always like to use this. It's a very, very good GIF over here. Positive mindset. Last 3. Alright, time's up. Okay. So what can we do over here? What can we do over here? Now, we know in this case it's 34, and since this is isosceles, what other angle we can take note? Because I'm looking for FBC. Okay, Denise, if your phone is very small, we have this particular property that you can zoom in your phone. So maybe it works for you better. Okay, as such. Now, next up, what happens is over here. Okay, I know this is 34, and based on the previous part, I can also make use of OBF. Take note, what are the angles I can find? It consists of 2 angles, OBF and OBC. So what is OBF? We have done this just now, isosceles triangle. OBF is equals to BFO, this is equals to 34 degrees. Why is this so? Because they are the base angles of my isosceles triangle. Now next up, what happens? What is another property that I can use to solve this question? I'll bring this to a open-ended question. What is a property I can use to solve further for FBC? So I know this is 34. I definitely know this is 34. This is 34. What is another property I can use to further solve for my angles FBC? Anybody else wants to try? FBC, what can I have? Okay, one additional step needed. Very good, El Nico. Good job. Okay, but why is it a right angle? I think you guys got it. Why is it a right angle? You have to state the reason why. The question says, fine, given your reason. So over here, I'm stating the reason. What is the reason over here? Why is it a right angle? So if I know it's a right angle, 90 plus 34 is equals to 124, which is the answer, last one. But what is the reason why I can say OBC, it's a right angle? We went through in the recap just now. You have to say tangent. Very nice. Perpendicular to radius. Most of you got it. Good job. So this is the reason why you have to understand geometrical properties, because they'll ask you to state the reason. Very important over here. Okay. Alright. We just have actually, let me see, 2 more bubble questions to go. Let's give it a shot over here. So we have, okay, let me just write it down for you all. Recall this is isosceles. This is 34 degrees. Okay. Find DFO. Now, looking at this, do we actually need anything else? Let's take a look. DFO. How do I solve this? Okay. In fact, you only need this. This is enough. Launching the bubble launcher. 3, 2, 1. Let's go. Give it a shot. Let's go. Alright, don't rush. Don't rush. Alright, don't rush. Okay, take note. Again, what is the angle you are finding? Always remember, you can use your previous parts to help as well, but in this case, you only need this much. DFO. What can I use to solve? Recall as well the properties given to you. DF is 30, 56, 69. 30, 56, 69. What can I do further to solve? Okay, regardless where you are, remember you guys are always doing awesome. Hang in there with me for the next 43 seconds. Last 34 seconds. Alright, doing good. Okay, I'm seeing good responses over here. Alright, hang in there with me for the last 10 seconds. Alright, doing good, doing good. I'm seeing good responses over here. Last 3, 2, 1. Good job. More than half of you got it right. But let's see how we solve this for the rest who didn't get it right. Alright, don't worry about it. Let's solve. So let's look at this. DFO. I'm looking for this. Now looking at this, let's zoom out a little bit. You realize I have a triangle in DFO. For DFO, if I were to bring it up. So this is my triangle. What else do I still need? Now I realize if I solve for DFB, because it consists of DFO and OFB, I can actually get it. So let's carry on. So I have DFB. Now solving for DFB is just 180 degrees minus 56 degrees minus 69 degrees to get me DFB. In this case, it's going to be 55 degrees. This is the angle sum of triangles. Angle sum of triangles, 55 degrees, because I'm just making use of this property, subtracting this and this to find this whole angle. Now with this over here, we can finally say, oh, I want to solve for DFO. DFO is 55 degrees minus 34 degrees, which is given to you beforehand for the answer. 55 minus 34. This gives me 21 degrees. And that's why my answer is number 1. Most of you got it right. Good job. But for those who did not, I hope you realize that you have to be very strong in your geometrical properties. Regardless circles, regardless triangles, quadrilaterals, or even straight lines just involved, you have to get this down. Okay, now, final question for today. Okay, finding angle EDF. So, I will write down for the angles that you need to know. In this case, my first one is my first angle. Yes, you will need this angle. This is 21. This is 34. You have these two angles over here. And you will need this angle as well. Solve for the previous part, 112. I want to now solve for angle EDF. Take note, what is angle EDF over here? Okay, I need this angle. How do I do it? Launching the bubble launcher in 3, 2, 1. Let's go over here. Last one. I think this one is rather hard, but let's see how we can tackle this. Okay, so this one requires you to zoom out your content a bit more, but seems like everyone is doing a good job. Okay, so zoom out a little bit more to actually check out. 1 minute left. Take note, I want EDF. Okay, so look at the question carefully. I need EDF. Okay, Irvin, I hope you are still with me because I think this is quite beyond already. I hope you are hanging in there. And for the rest as well, hang in there with me. That's good to hear. Just hang in there with me, alright? It's the last one for today. And I hope you get the content down. Very important. Last 20 seconds. Last 15 seconds. For those who have yet to be done, you're almost there, almost there, almost there. Alright, last 3. Okay, yes, based on the response, I agree this is one of the hardest ones, so let's take a look. Now, angles EDF. Again, try to zoom out from the picture if you realize it's unclear. So, some of you may think, okay, I can solve from this triangle, right? But the thing is, I don't know this angle. Don't assume it's 90. It cannot be 90. Take note, it's not 90. I, therefore, cannot solve this angle. Correct? And some of you may think, oh, this is 90 degrees, right? I can just take subtraction. If the question never say, do not assume. Only use the values given over here. Only use the values given from here. Very important. If they do not give you, you can use it. Okay, now what can I do further from here? Let's try to see what I can have. So, let's zoom out. This triangle over here, nothing much. Everything is solved. What is the biggest shape I can get from here? You realize I have still left my quadrilateral, and this one special name, cyclic quadrilateral. Very important. And let's see. Oh, you realize EDF consists of this angle, and this angle. What can I do? You realize further, if I were to actually find out EFB, let's do EFB is then, take note, in this case, 30 degrees plus 21 plus 34 degrees. This is 85 degrees. And that's where you have your other property, EDB. Follow the blue color segments. Blue color arc, blue color arc. Because this gives me 180 minus 85 degrees. This is equals to 95 degrees. And the reason is, recall, it is easier to see by angles in a cyclic quadrilateral, or opposite angles in a cyclic quadrilateral. But easier way to write it is angles in the opposite segments. Okay, that's the name that you should write down. Angles in opposite, spell it out, segments. Then finally, we know since this is 95, can move further and solve for angle EDF. It's just 95 because it's EDB minus 56. This is equals to 39 degrees, and henceforth my answer is number 3. Okay, so a lot of properties you have to know. Try to zoom it out from the further picture if the figure does not help you. Those are some tips that you can do. And with that, that is actually all for today. Try yourself for Genie Ask. Give it a try to see whether you can solve this. 40 bubbles up for grabs. Different properties. Not only you get to reinforce your concept, you get to solve this as well. And that is all for today for Night Geometry and Measurement Revision 1. Hopefully, after this revision, every concept, every property is recapped as well. And yes, that's all for me today. So, thank you for joining me for today's lesson. I hope this revision is useful for you all. But until then, stay safe, and I will see you all next week. Same time, same day, 2 p.m. This is Teacher Jason signing off. Take care, everyone. Bye-bye.